Hey guys, this is David Ginnig with Advanced MasterCAM, and today we are going to be working on Project 7. Now, Project 7 is different than all the other projects we've been working on thus far. All the other projects we have been creating the solid, and that we may have been doing some machining work on them, we may not. Today is actually going to be a process of we're going to be importing files and machining, concentrating on machining this project. So let's go ahead. A couple things you need to have set up. You need to have access to these two files, project7.stp and project7casting.stp. These two files were created in another program, and we're going to import them into MasterCAM, and they're solids. STP is or STEP is a file format that's really interchangeable between solid modeling programs. So the first thing we're going to do is we're going to open up that STP file. It's Project 7. So we'll go to Open. We don't need to save the current file. Coming to desktop here, and the file name over here. Right now we're running X8. You may be running X9. We're going to click down on here, and we're going to look through this information here until we find STEP, which is right here. And once I do, looking in the folder that I have those two files in, I see project7.stp. Hit F9, and here is the solid. Now I'm going to go ahead and set this stuff up here. I'm going to change this to my solids. I'm going to create a new layer 2, and I'm going to create this as my CAD. I'm making sure level 2 is what I need. Because as we're going through machining this, we may pull edges from this and use it for guiding our tools. Now, what's going to be interesting about this project is we're actually going to be using a model of a casting part as though it was received from the manufacturer. So we're going to need to get that solid, and we're going to need to put it in with this solid. So what we're going to do is we're going to do File Merge / Pattern. We're going to navigate to, in my case, desktop. That's where I'm keeping the files. Wherever you keep the files, navigate to it. I'm going to look for the STP file again, or STE step file. Let's see, there it is. And we're looking for Project 7 casting. It's going to come up with this prompt here. There's create surfaces. We're going to import solid faces and stitch them. And that's going to create a solid for us. Now, if you can see it here, we actually have two solids now almost overlapping each other. I'm going to come to levels here, and what that did, the import did, was create a new layer. I'm going to change that to casting, and I'm going to turn the visibility of solids off. So here's what a casting would probably look like from the manufacturer, with nice filtered edges. There's machining allowances, and our goal is to take this casting to this finished part. Now we only imported this because we needed that file in order to drive the stock. So let's go ahead. We're going to set up a machine type. So let's go take a view. Let's make sure toggle Toolpath Manager's on. So we have this tab down here. And we're going to go ahead and load up a machine type, a mill, and we just need a generic Haas 3X mill. Now we're going to open up the properties of this Haas. And the files, we're going to leave all that the same. Tool setting, I like to assign tool numbers sequentially. All of these 4 items. So if you can give the program a name, that's your O, 1, 2, 3, 4, 5, whatever value you want. That'll put O, in this case 5, 3, 6, 8. So for stock setup, this is where we're going to actually, when we simulate it, we want it to look like our casting. So what we do here is we're going to change this to solid, and we're going to use this icon here to select the solid we want to use. Now, in this case, the casting. We want to change this to display, and we want to set it to solid, and go ahead and approve that. Now we can come into levels, and we can activate layer 1 and turn off the visibility of layer 3. And there you go. You can see the red outline is the stock. So when I go to simulate all my cuts, it's going to use that as my stock material, and we can tell if we're actually making all our cuts or not. Now if you're not seeing this, the visibility of your stock is controlled up here. There's turn stock shading on off. There is turning show and hide the stock. So I'm going to leave mine on. We'll go from on and off. You'll still want to keep this casting here, because you may need to come in occasionally and make measurements from the casting to the finished part. So we'll go ahead and turn that off. I'm going to keep it on layer 2, so any cat I create. So okay, let's go ahead and get started. Now we're in WCS top. As you see, WCS top, TC planes top. And when I click this button here, top WCS, we are looking at this face of the part. And to give you an idea, that would mean that this part is basically sitting in a machine where the bottom of the part's sitting on the bed, and these features here are pointing up towards the spindle. Since we are currently facing that way, we're going to go ahead and machine or create our new world coordinate systems, create brand new world coordinate systems to machine this thing. So let's consider that, let's say our fixture for some reason uses this bore to kind of locate this into the machine. So we're going to put 0, 0 right here in the middle of this bore on the bottom of this part. And we're going to do it, let's do it on the bottom of the casting, not the bottom of the trim part. So we'll come back, we'll turn the casting back on, the finished part back on, and we want our origin to be the center of this bore. So let's go WCS, let's go plane manager here, and I'm going to click on solid face here, and the face I want is this one. Now you're going to get this this new WCS pointing up, and it's going to indicate which directions our X, Y, and Z axis are. Right now our Z axis is pointing the wrong way. We need it to come up from the other direction. So there is possibly an appropriate one. I'm going to say this is going to be laying in the machine where the X-axis is, the negative X-axis is going to the right and to the left at this view. So this shaft is going down the negative X-axis. Right now it's saying it's going positive X. So we need to thumb through our options until we get this. That means our X is now going to the right, our Y is going up towards the back of the machine, and our Z is going up into the spindle. And it happens to be right at the center of our bore, which we're good. So we'll prove that. We're going to call this operations top. And just for the purposes of learning here, we're actually going to start assigning some new work offset numbers. So I want to check here. We're going to get a unique, the way MasterCAM sets work offsets is it does a number between 0 and 100. So 0 would be our first offset, which would equate to G54 in the Haas machine. Work offset number 1 is G55, work offset number 3 is G56, and it keeps adding and adding. Now the post processor may not be set up to go past G59 correctly, but for now we're just going to be dealing with this. We're going to give it a unique work offset of 0. And we're going to set our construction in our tool plane to there. So we got operation top, work offset 0. So now you can see down the bottom, looking at our new blue axis, or origins down here at the bottom. So is this the best setup? Maybe, maybe not, because now all your tool operations are going to be in the positive Z axis, not the negative Z axis. Could possibly increase the chance for tool collision, but probably not. So let's go ahead and turn the casting back off and turn the finished part back on. Okay, so what do we got? What can we do in this orientation? We can deck the top of this to the top of this tab here. We got to machine all this off here. And if we want to, we can also machine this. And I think that's probably a good thing. So let's see how we want to do this first. To machine this face, we can't just grab the face and tell it to machine it. We're going to actually have to create some tool guides for the tool to follow, if that makes sense. Trying to think what's the best way for us to do it. So what we want to do is have the tool come in. We're going to get a big enough tool that when it hits the center of this boss, it's going to be hitting everything as it's coming around. So it's going to come and take off this edge here, right up to the edge. And then it's going to come down through here. It's going to come over, down all the way through here. Reverse direction. And then come up through here. And then come off. This is likely not going to be able to be done in one tool path, because as we're coming around, we're going to leave, say right here where it's coming down off this face and down this way, it's going to leave a little bit of a fillet here. Then we're later going to have to just come back and do another operation and come around that point. So let's see. Let's go ahead. I'm going to measure some stuff here. So tool, analyze, distance. I want to know how far across these two are. And it's roughly, it's a little under 3/4 of an inch. So I'm going to actually use an inch cutter. And we're going to probably, instead of doing offset or tool cutter comp, we're going to draw a line basically down the center of this part that's away from the wall a little bit more than a 1/2 inch. So let's go ahead and see. I'm going to analyze another distance here, because we want to know the distance between these two. Actually, this is a better one. 0.6563. So let's do X form offset. That one, this direction, 0.6563 divided by 2. I'm going to do another one here. And okay, so now let's see. We're basically going to create a chain that comes down here in the back and around back off. So let's improve that. Our distance on this again, from here to here, is 7181. Let's do X form offset from here to here. Oh, I'll flip the direction. 0.7181. I'm going to take 10,000. I'm going to take 20 thousandths out of that, and then divide that by 2. Oh, we need to have a parenthesis in here because orders of operation is important. So 0.7181. I'm going to take out 20 thousandths of it and then divide that by 2. Okay, I got a syntax there. So parentheses 0.7181 minus 0.02, close parentheses, divided by 2, enters. Okay, that's the value I'm going to want. Reason being is I don't want these two chains to overlap 100%. It'll cause it can cause a problem in how it changes. So I'm going to plus arrow and get that one over. And as you can see, these two lines now are 20 thousandths or 10 or 20 thousandths apart. So let's extend some lines. Oh, I need to offset another one. So let's offset this line here. Didn't do what I wanted it to do. So this line here. Oh, it's going the wrong way. That's why I can't see it. And we're going to want 550 thousandths. The reason being is we have a 1-inch cutter. I want to leave 50 thousandths on this wall, and we're just going to run the cutter straight down this line. So let's approve that one. Let's do another one here. Okay, so now let's go through and we'll trim everything up. So divide, delete, we want that gone, that gone, that gone, and that gone. We need to extend these guys. So let's do an extension of 0.5. Extend that one, and that one. And we want these guys to go past the end of So come back to divide, delete. That line, that line, that line, and that line. Let's take a line and basically connect the two. I'm going to do auto cursor nearest, and all that means is I can basically place it anywhere I want on this line. So nearest to there, and let's turn some stuff off here. Perpendicular to there. Okay. Trim, divide, delete these guys back. So now I have a nice line that starts here, goes around, down here, over, back down. Now it's really kind of cutting air here because it's already made the cut. Back around and off. Prove that. I'm going to turn my visibility of my stock off. So we're going to use that chain to drive it. I'm actually going to change the name of this CAD from CAD to Toolpath. Toolpaths. That's another thing I like to keep separate, is the CAD and the toolpaths are separate. So let's go ahead and want to analyze how deep this cut is here. We can do that just by looking at a print. It's 313. Well, we're going to be using a half-inch cutter. Half-inch cutter, say this is cast iron, so we're probably going to be using a 4-flute. That means a maximum depth of cut of 1/4 of an inch. Let's just say that's the requirements of the tool. So I need to do this in multiple passes. So let's go mill toolpath. We'll do contour. Whatever name you want to call it, just go ahead and improve that. And I'm going to select this chain all the way through. Let's go ahead and pull up our tool. I want to actually create a tool. We're going to create our tools as we go. So we're going to create a new tool. It's in mill. Next, we're going to be using carbide basically. So we'll do a cutting diameter of 1. Overall length of 4 is fine. Cutting length of 1 inch is fine. Quarter tight. We have no corner. Shoulder length 1.2. That's all good. So next, we'll call this tool number 1. The feed rate. Let's use an SFM of being it's carbide. Normally we're at around 80 to 100, so we're going to multiply it by 3. Let's use 300 as our SFM. So pulling up our calculator, we have 4 times 300 divided by 1. So 1200 RPMs is our spindle speed. So now we'll do 1200 RPMs. Oop, put it in the wrong spot. 1200 RPMs times 4 flute times, we use a 5,000 ship load, 24 inches a minute. So 24 on a feed rate. Plunge rate, do about half of that. Retract rate, I like high speed retract rates because it's annoying to watch this thing come up out in the air real slow. Clockwise number of flute we'll call carbide. We're going to say we want the coolant on in this case. We may not. We'll call this 1 inch, 4 flute, carbide. The milling, rough step, we're going to use rough steps, probably 40 here, rough step is 20, finish 15 and 10. And this is more for dynamic milling, which we're not doing here. So let's go ahead and finish. What's nice about creating our own tool is these feed rates and these spindle speeds are locked in here, and along with the feed per tooth. If I pull it from the library, this stuff is not locked in here and I have to change it every single time. I do like rapid retract here. Holder, we're not going to worry about that. Cut parameter, we have contour type and we have a computer, so we're going to actually turn this off because we want the tool to follow, the middle of the tool to follow that line. Internal quarter radiuses, we're not going to worry about that. We're not going to worry about stock to leave. We're going to come down to a finished mill. We do want depths of cut, so maximum depth of cut is 250 thousandths. And then we'll leave this, we won't put any finish cuts down. We will keep tool down. And we'll need on lead in, lead out, so we're actually going to turn all this off. not completely off, because we're going to adjust our contours. Now what this does is it's going to say at the end, we start our contour over here, and I may need to flip its direction because we may be conventional milling. What I'm asking it to do is extend the length of this contour by 50% of the cutter. We also want to extend it by 50% of the cutter. That means this line, it'll come another 50% of the tool out past the part. So we're going to verify whether we're going the right direction later on. We don't need breakthrough, we don't need multipass, we don't need tabs. Now linking parameters. The top of stock is actually, we got to turn on our casting and snap to something up here. So our top of stock is here, 2.8125. Depth, you can leave an incremental. What that means as incremental, let me turn the solid back off. Oh, we can't yet. The incremental means basically what chain did we select. If wherever that chain is located, that is the incremental 0. Now if you want to, we can switch this to absolute depth, turn our casting back off, and select this CAD. 2.40625 is the same as an incremental of 0. There's no difference. So we're going to leave it incremental 0. What the incremental does come in handy when you start doing machining where there's multiple depths rather than just one depth. We've got to check that our planes WCSs are different. So right now we're going to change this to where it says Operation Top. Operation Top. Come back to our linking parameters and make sure everything's still good, because this information here dictates a lot of these numbers here. So we got retract here is incremental. We're gonna increase that to ½ inch, so it's increment ½ inch above this CAD line. Remember, we have a casting here we got to clear. So feed plane is, let's go, feed plane is also 0.5. Let's do a retract to 0.75. And this is incremental above this. Now we can, let's set an absolute feed plane actually. Turn our casting back on. Click here, and then we're going to add 100 thousandths to it. And let's also do that with our retract just to make sure we clear everything, and we'll add 0.5 to it. So now this is all set to absolute except for our cutting depth. Coolant, because we created our own tool and we said coolant is on, coolant is always on for that tool. So let's approve that. Now, so there we go. We have the, oh, way the heck out there. I think we value is way off. Let's go back into parameters. The lead in, lead out is way off. Okay, tool diameter is 1 inch here. Lead in, lead out. 50% should be 0.5. Something's going on here. This is a weird glitch. For some reason it thinks the tool is a lot bigger than this. Tool diameter 1.0. And lead in, lead out. We had 50%, which should have produced a length of 0.5. It's producing a length of 5,000. So we don't want to deal with that, so we're going to go ahead and do it empirically. We're going to tell it extend it just a ½ inch. And these arrows right here take this information and push it over to this side. This goes the other way. So let's go ahead and regenerate that tool path. And there, that looks a lot better. However, I want to go ahead and turn the let's turn this back off, turn the solid on. See, we're colliding with the part, which isn't good. Let's also take a look at our geometry and make sure we're going the right way. Now what this is saying is I'm going this way and the tool is cutting clockwise, so we're conventional milling. We need to reverse the chain so that we're starting over here. Now we're climb milling up these walls. Regenerate tool. We are still colliding with this, and that has to do with keep tool down. So let's go to parameters, depth of cuts, uncheck keep tool down, regenerate, and now we are clearing the part. So it'll come around, jump back up, come back down. Let's take a look at the simulator. So pull this up. Wrong button. And because we had used the solid as our stock, you can see this is what it looks like. So let's go ahead and push play and see what we get for machining. So there we go. It came around and it made it all the way to the end, made everything all the way through, and as you can see there's two. We still have some more refining cuts to make on that, so let's do that next. And we can do this in one depth. So what we're going to do is I'm going to duplicate this CAD, we're going to connect the two and round them off. So create curve on one edge, this edge here and this edge here. Now we're going to extend them until they touch. We'll now trim them back, and I will also give them a fillet of 1/4 inch is fine. See? Now what's going to happen is I'm going to use that, the tool's going to follow that, and this time we're using cutter comp. It'll come out and make that cut. So let's come down here, we'll do mill toolpath, contour, we'll select that chain. We're going the wrong way, so we'll reverse it because we want to make sure we're climb milling. The tool we're going to leave 1-inch flute, and because we created it, all this information sticks. Cut parameters, we do want computer. We're going to set this to computer to do our cutter count for us. 0 stock. We're not going to do any depth of cuts this time. We're going to do it all in one shot because there's very little material left. Lead in and lead outs, we're going to leave these off, and we're going to extend it maybe just a little bit more. And what that means, because we got nothing out here, it doesn't hurt it just to come straight in and straight out. We don't need to do any ramping. Linking parameters, this is all still good. It held over from the previous. Make sure our planes, technically this is correct, but I want to make sure it's orientation top. Coolant is still going to be on, and we're ready to approve it. The only problem is our toolpaths are on the wrong side. Easy to fix. Open up our geometry. Green arrow, big arrow indicates the direction of cut. Little green arrow means side of cutter compensation. So all we got to do is come here and change sides, and that's what we want. It's going in the right direction. Reproof, and now you see this big arch. So let's simulate and see what we get. Zoom out a little bit. Let's go ahead and play it. Oh, we missed our last one. Forgot our other toolpath. I like to do colors so we know which path is which. So it's going to come in, do the yellow, and for some reason it totally missed. Something's going on over here, so let's take a look, pull up. Huh. Oh, I see. Our mistake is actually in our first chain. See this right here? It's going too far. So we need to come back and correct our first chain. So let's do Alt-T. Right here, we'll just make sure both of these are checked and click this, and that turns off our. What's happening is this line right here is not 550 thousandths. So it's cutting way too deep into it. So let's X-form, offset this line in this direction. Oh, it's going the wrong way. There it is, 550 thousandths. Now let's trim everything back up the way we're supposed to. Now when I trim this, it's going to give me a warning because I'm using this CAD to drive tool. I don't want to save the CAD, so it doesn't matter. Let's trim that. Oh, I thought it would give me a warning. It didn't. But see how the toolpath is now dirty here? We've got to come back and reselect our geometry. So rechain all, starting here, coming around, down here, back around, and up to there. The cutter comp really doesn't matter on this one because we're not compensating. Now let's go take a look at our simulation. 2, there we go. So that's exactly what we're looking for. You can see where it had 50 thousandths material came through. Now we have this notch. Now let's see, there are a couple more operations we still have on the top. One is milling this top flat, and the other is running out this notch here. So let's go ahead and, while using the same tool, let's go ahead and deck that off. So mill toolpath, this time we're going to face. We're going to do this is wireframe and this is solid select. So let's go to solid select. All I want is a loop of this. Oop, see, I don't like that loop. Other face. There we go. That's the face I'm looking for. Direction is not so important. We're going to go ahead and use the same tool. This time cut parameters, we're going to do, hopefully we're going to try one pass and see if it'll do it in one shot. Now with facing, it always puts a stock to leave on floors here. We're going to zero that out. We may come back and change the roughing angle, but for now leave it at 0. Linking parameters, we'll do top of stock. Let's see. Let's turn top of stock back on. We gotta need our solid to do that. So that guy, prove that. Oh, okay, we'll just move this up here and up here. I'm copying and pasting it. I'm adding 100 thousandths to the feed plane, and I'm adding 500 thousandths to the retract. Depth will leave it 0. Planes, we're going to fix that. Coolant should be on, and we're good to go. So it tells me the diameter is not enough to do in one pass. We want to save the operation, so we're going to close it down. I'm going to go back into here, turn that off. I'm going to try to, right now it's trying to go from 0 at 0 degrees. I'm going to try to see if I rotate the roughing angle at 90 degrees and see if that'll give me what I need. Let's see if that will do it. There we go. So it was trying to come across this way, and it's too wide at these points for that cutter to actually knock that off. But I can come across this way and be just fine. Okay, so as always, let's highlight all of our tool paths and let's simulate it. Okay, we are really close now. Let's go ahead and cut that notch out. Still using the same tool. So, how do we get this notch to work? Well, let's go ahead and just go create curve. Actually, we don't even need that. We're going to use the edge of that solid to drive the tool. So, mill toolpath. We'll do another contour. This time, instead of wireframe, let's do solids. Uncheck. All we want is just the edge highlighted. We want that edge. And we do want it going in that direction. The direction is important with contour because we want to make sure we're climb cutting. So the tool, still the same tool. Cut parameters, we want computer compensation. Everything's left at 0 here. Depth of cuts, we are going to want depth of cut of 250. I'm going to exit out of this. I want to know how deep a cut we're doing here. 250,000, so we can do it in one pass. Let's go back to mill toolpath. Contour, selecting that line, but the other direction. Tool, it's 1" 4 flute. Cut parameters, we don't need a depth of cut. We do need lead in, lead out. Lead in we can do at 0.5. However, lead out needs to cut all the way, because this is still solid over here, so it needs to come all the way out. So we're going to do, say, 2 inches for now and see what that looks like. Linking parameters, let's do top of stock this time here. Copy that up to these two. I'm going to add 100 thousandths to that one and add 250 thousandths to that one. The reason why this keeps showing up as top, even though I have TC planes or operation, see WCS top, I'll show you how to fix that so we don't have to change this every single time. Okay. If you notice here, it did not extend my chain. Let's try doing this. See, now I got that weird. See, something's going on really weird with this thing. I'm not sure what's causing it. 0.75 inches here and 2.0 inches here. Regenerate toolpath. And see, now when I do that, it's not doing it. Okay. So what I'm going to do this time is I'm going to create a curve on one edge. I'm going to rechain it using a wire rather than the solid face. So come to geometry, rechain all, switch over to wire. I'm going to select that chain. It's going in the right direction, compensation on the right side. Regenerate. Man, still doing it. Let me use some ridiculous numbers because I'm getting some kind of glitch going on here. Huh. Okay, well I'll keep messing with it. So 150, 300. Well, better, but not good. That what I'm doing here does not make any sense. I'm going to go ahead and leave that, but for some reason there's a weird correlation between those numbers and the diameter of the tool. So now I'm coming in far enough and coming across, and I'll be cutting enough of that out. So let's go ahead and review what I'm showing you on that lead in lead out contour thing. It's not correct. But sometimes this program will throw little bugs at you that you got to deal with. Okay, so we got this to come all the way across and cut our casting all the way across. Oh, you know what? We do have one more operation that we got to do, and that's the inside of this part. What's going to be the best way to do that? The amount of material we have here is actually pretty heavy. We're going to assume that we have a reduced shank 1-inch cutter. Basically that our cutter, if we take this 1-inch cutter and we're going to mill down through here, that it won't, when it passes the flutes, it's not going to rub the wall. So let's just make that assumption in this particular part. So we're going to do a mill toolpath, and we're going to use a drill. And our drill point, we can use the center of this, is there. The tool we're going to use, we're actually going to do a helix bore. The tool we're going to use is this 1-inch flute. All the information's fine here. Maybe it's this head number. Why is this? Weird. Okay, so cut parameters. We're going to take everything out on this. Leave everything to computer. We're not going to do a rough finish. We're just going to leave it one pass. Let's go. 180 thousandths is pretty. No, it's fine for a 1-inch cutter. So linking parameters. We need top of stock is actually going to be up here. Feed plane is the same spot plus 100. let's go ahead and just copy this. So copy this, paste it to here, and I'm going to add 0.25. Oh, I forgot to tell you how to change that. Basically what it is, this WCS is still set to top. Oh, it moved to operations top. Well, that's because I changed it here. It's showing up there now. Coolant still on. Okay, prove it. Oh wait, depth of cut. We need to fix that. So go back to parameters, cut parameters. Sorry. Linking parameters. Depth, absolute. We want to set it to 0 because our origin is at the bottom of the part. So it's going to cut all the way down to that point. Regenerate toolpath, and there we go. We have a helix cutting operation where the tool will go through and bore out that hole for us. Now, how do we change this WCS top? We just come here, name planes, operation top. So now every time I select, even though we're done, every time I select an operation to do, it'll use this information filled into there. So let's go ahead and look at this tool, simulate this tool path, and see what we got. Okay, there it is. Nice and fresh. So I think what we'll do now is we'll flip the part over and we'll do this part, and we'll use the center of this hole. Let's say we have a fixture that we put this on at the center of this hole, and we're indexing around that boss at this yellow face. So let's go ahead and come back here and let's create some new WCSs. Let's hide all these tool paths. So let's create a new WCS. This time this boss will still be coming off left, this part here. WCS is plane manager. We're going to do a new one from solid face, and we're going to select that face. I don't like its origin yet. We need the Z pointing in the other direction, so let's thumb through these until we got the Z going the right way. The X is going the wrong way, so let's thumb through these. Okay, X is going to the right, Y towards the back. That's what I'm looking for. Now it's not in a good spot. I'm okay with the Z depth, but we're going to change the X here to 0. It may not let me do it here. No, it's not going to let it do it here. Let's get a unique offset of 1. Call this bottom. We did operations top, right? So operations bottom. Now we're going to need to change that. That origin needs to be in the center of that circle. We know that that circle's centered. Well, that circle is centered around 0. So let's just change that to 0. Hit enter. Now it moves it to the center. So that's what we're looking for. Okay, now we got to change everything over here. I'm going to show you how to do that. We can come to WCS Plane Manager. See how this icon means the WCS. So if I click there and click this button, it moves it down. Click here and here, that moves construction and tool. And we have, coming back to Plane Manager, see we have a WCS, a work offset number 1. So this would be G54, this would be G55. So if you were machining this in your fixture, you'd have one spot on your fixture which would have it one way, and you're moving it down your fixture, and each position has a unique offset. Okay, so what do we got to do on this side? It's 2 simple problems. We have this surface takeoff and this tab takeoff. Let's go ahead and start with that tab. Do contour. Now we're probably still going to have some of those weird problems here. Hopefully you are not having that problem. I'm going to use a solid edge. It's going the wrong way. Wait, no, that was the right way, because we want to make sure it's climb cutting. Tool. Still use this 1-inch tool. Cut parameters. Leave it on computer. Everything's at 0. Depth of cut's 0. Lead in, lead out. We want to adjust lengths. This time let's flip them. Now I want to discuss this a little bit here. This length, this is an absolute. So if I were supposed to put 0.5, it's supposed to do ½ an inch. For some reason it's doing something weird, and I'd put 0.5 over here, would be ½ an inch. The percentages is based off the diameter of your tool. So I could have put 50 and it should have put ½ inch in length. It's something weird's going on, so I've got to fiddle with it and basically confuse it, because it's confusing me. Okay, so let's go adjust all these. Top of stock in this case is at the edge of that casting. I'm going to propagate these all up and then add my 1/4 inch to that one, add my 100 thousandths to that one. Oop. In depth, I think is already there. Yep. Okay, so now when I go to planes, see how I have, because I had my WCS already set to operation bottom and TC planes bottom, you'll see operations bottom, and tool plane and construction planes are grayed out as top. This is actually correct. If you see top grayed out, don't worry about it, that's what you want. If it's not top grayed out, just select the operations bottom and it should fix it. Okay, well, I'm happy with that lead in, lead out. Next thing we're going to do is, let's go ahead and do similar operation that we did to the front. No. Let's use a bigger tool. Let's just pull up a 3-inch shell mill this time, and we're just going to deck this thing right off. So we'll go mill toolpath, face, or we could just go ahead and use that 1 inch. Let's just go ahead and use that 1 inch. I'm going to select that face. Oh, nope, we don't want that. No, actually we do want this. If you select, don't know which face it's grabbing. If you select both the outside chain and the inside chain, that would be trying to attempt island pocketing, and it doesn't know how to do that. So you just want to make sure you have the whole circle selected. We'll approve that. We're not going to pull up a new tool yet. We're still going to use this 1 inch cutter here. Whoops, I accidentally opened it. Cut parameters, we're going to set to zigzag. Max step over, let's do 40% of the cutter's fine. 0 stock to leave. Depth of cuts, we're not going to worry about that because it's only doing 120, it's only doing 1/8 of an inch cut. Depth 0. Top of stock, let's turn our casting back on. Top of stock is actually here. Let's copy that up, add a 0.25 to that one, and a 0.1 to that one. Okay. Arc filter tolerances, don't need to worry about that. This is all set up correctly. Coolant's still on. We'll approve it. There are duplicate chains in the pocket. I only need one of these. Delete that chain. I don't know why we must have selected 2 somehow. There we go. So this is the machine coming through, cutting out. It's cutting some air, but it's effective. So let's pull up all the tool paths. Pull up our simulator. You'll see some operations being done on what appears to be the bottom. That's just the operations done on the back side of the part. There it is, boring through for us, and now it's cutting up the back side of the part. So we're now getting pretty close. All we have is operations on the end, and we'll be done. So let's keep moving forward. Turn our casting off. Now, I'm going to say we're going to have some kind of fixture where we'll put it here. This time I'm going to, it's standing up like this. This time I'm going to put the origin right in the middle of this, how would we do that? I'm going to use this machined feature here, and right in the smack dab in the middle is our WCSs. And turn off all our tool planes. So let's go WCS, plane manager. We'll do a solid face, and this time we'll select this one. Now, how is this going to be sitting in the machine? I'm going to say for the heck of it, it's sitting this way in the machine where the Y is going towards the back. So there is the orientation I want. It's not in the right location though yet. Operations side, we'll call this. We'll give it its unique offset. We'll approve it. I just zeroed these guys out, and now it moves it towards the center, but I'm okay with the Z height. So let's go ahead. I'm going to show you how to change the CT plane and operations another way. So approve that. So come down to WCS, name plane, operation side. And then we come to planes here, operation side. So doing that changed our WCS to operation side and our TC plane to operation side. Now all we got left to do is I'm going to mill this notch off the top, mill these guys out, and also bore that hole. Let's keep using that 1-inch cutter. How about that? Let's do this whole part with 1-inch cutter. So mill toolpath. We'll do a contour. Come do this little guy first. Make sure we're on solid select. We're going to select just an edge. That edge. Make sure we're going the right way. That is the wrong way. That's the correct way. Tool. Still using this guy. Cut parameters. We're good with that. Computer. No depth of cut. Lead in, lead out. Let's try this again. 0.75 here. 0.75 here. We don't need anything else except maybe linking parameters. Now linking parameters should change. The top of stock is here. Actually, top of stock is not there. Let's okay. It kept it, which is good. Top of stock. Turn our casting on. It's actually on the end of our casting. Feed plane is 0.225, and we'll do 1/2 inch for retract. And depth, we'll leave it incremental because it's at the bottom. Prove that. Regenerate. Okay, my lead out's looking good. My lead in looks weird. So we got to go back and cheat it. Lie to it again. Oh, it's because it's at 100. So I'll do 100 on this. It's almost though as it's taking the length as percentage. So I'm not worried about it. It'll be achieving what we need. Okay. So that will come in and cut that off. We also need to cut the top of this off, but I'm going to come cut this out first. So, mill toolpath, and there's some changes we're going to have to make to our toolpath here because the way it's currently run is not working. But let's contour using that line. It's going the right direction. Tool, same again, 1-inch 4-flute. Cut parameters, leave that all the same. This time we are going to engage depth of cuts. I will do one finish step 2. Just taking a lot of material. We'll do a 50 thousandths. We'll keep the tool down this time. Lead in, lead out. So we will need a lead in. I'm going to say 50, and then I'm going to increase this to 200. Let's see. We will also be doing multi-passes. So we'll do. Let's see what our distance. Oh, we can. I'm not sure. Let me do it. Okay, so we'll have to guess. So we'll do 3 passes at 40 thou. We'll do 1 pass at 15 thou. Linking parameters. Top of stock is all these tops. All this information is still okay. So let's go ahead and prove it and see if it goes far enough. So it looks like it might. I'm going to increase the lead out to 250. Yeah, that looks a little bit better. I just want to make sure that it's coming across and cutting the whole thing off. So now we need to come and we'll face this guy off. Do a loop select. Other face, approve that. That's okay. Tool, this guy, cut parameters, one pass. Depth of cuts, we don't want depth of cuts. Linking parameters. Top stock is 0.125. This is, I'm just pulling this from memory. 0.225, absolute 0.5. Depth 0. Okay. Plane should still be operation. Okay, let's prove that. It says it doesn't like it because it can't cut it in one pass. I do want to save it because all I need to do is change the direction of the roughing angle. Let's go back to 0. And see, you can do it in one pass that direction, but if you turn it 90 degrees, it can't do it in one pass. That's what it's fussing about. Okay, so one last thing to do. We're going to use that helical interpolation again. It's technically, let's go. Actually, let's set up a brand new tool. We're going to bore that. Use a boring head. Mill toolpath drill, and we're going to select the center of that arc. Prove that. I'll leave it at drill. We're going to tool, create new tool. Now looking at this, our diameter of this, it says ream, but we're going to bore it. So 1.376. A boring bar. Cutting diameter is 1.376. Overall length is 5. I'll say it's 5 inches. Cutting length is 1/4 inch is fine. Taper angle, well, that's fine too. Shank diameter is 0.75 maybe. I don't know if that's all correct or not. Okay, so 3 feed rate. We need to calculate our plunge rate based off of our finish. So if we want to have, say, a thou finish, how many revolution at spindle speed of 1,000, what's our feed rate? Inches a minute? That seems a bit big. Let's slow that spindle down. That section moving a little too fast anyways, so it's 200. I'm sorry, it's 0.001 times the spindle speed, which is a 0.2 feed rate. Let's bump it up to 300. So it's 0.3 feed rate. And maybe we'll do a 5,000 chip load. So 0.005. Let's do 3,000 chip load times 300. 0.9 inches a minute. It's pretty slow. Very slow, in fact. In fact, I'm not sure this math is correct. We'll go ahead and I'm going to so 1.376 boring tool. I'm going to leave all the rest of this. We're going to take this out and put in a bore 1 as a cycle. So finish. So basically, whenever I pull up the tool now, so there it is, feet per tooth is 3 thousandths chip, and that's per revolution. So it's doing 3 thousandths per revolution. So when I do cut parameters, this is a feed in, feed out, bore number 1. Linking parameters, we want top of stock to be 0.125, retract to 0.5, absolute, and depth. We want the depth to actually be, click there, it's a 3/4, let's increase that just a little bit. And that should be it. So planes are good, coolant, oh, we forgot to turn coolant on when we created the tool. Prove that, and it looks like it's a drill sequence, but it's not. So now let's go ahead and simulate this, make sure we got everything right. and then we'll go back and correct the one thing that we're missing from our tool paths. So here are the top operations. Top operations are done. Let's go look at the bottom operations. Okay, and now it's coming through. It did this little notch here. It's getting ready. It's coming back and forth on this guy here, doing it in multiple steps, and then it milled the top off, and then this guy is coming through and did a plunge. You can't see it other than it's dark yellow. So there you go. And this is the machining process of this entire part, except we got one little problem. If I post this machine's going to try to do all three operations at once. It's actually okay if your fixture's set up to do 3 at a time. But let's say we actually have to flip the part. You need it'll do one operation, then you want the machine to stop, and you take it out of that fixture position, move it to the next one. I know that's not exactly the most efficient way, but I want to show you how to do that. So you can stop the machine, have it bring it to you, allow you to move the part to its next location, lock it down, cycle start, and it goes and it finishes the other operations. So I'm going to shrink all these down because I'm going to isolate, try to figure out which one's which. So we have these contours and then the helix board. That's all to here is the top operations. See, operation top, and then we got the operation bottoms. I'm going to come in here and do mill toolpath, manual entry. So what I'm going to tell the machine to do is, let's see, it would be G53, that's machine coordinates, G90, G00, Z of 0.0. Why do I use G53, not G28? I've had G28, G91 erase tool length offsets and cause the machine to crash. Doing this one and doing this with the G53 is much safer. Now I'm going to do 154 P1. That's a work offset. That's above G159. X of 0, Y of 0. So what you're going to do is whenever you're setting up the machine, you're going to bring the table to where you want it at the door, and you're going to set that as G154 P1 offset. M00, flip part. Can't spell today. I can't type. We're going to say OK, and now we have a manual entry in here. Now I'm just going to copy that manual entry. I'm going to bring it from between operation bottom and operation top, and I'll paste it. Same entry. G53, G90, G00, Z of 0, and then G154, P0, M0, flip the part. Okay, so there we go. We have all the machining done. Let's go ahead and take a look at our post. See if everything looks good. We're looking for unique offsets, and we're also looking for manual entries. So let's see, we got the G54 here. Let's look for G55. There's G55 right after flip part. So we have here, this is our manual entry, G53, G90, G0, Z of 0. Brings the spindle up. Then it brings the table towards you, G154, P1, X0, Y0, assuming you set those offsets in the machine. Then it forces the machine to stop. You flip the part, you hit cycle start, and it goes on. And then there's another flip part with, I believe, a new offset. At least it should be. No, we did not actually set a unique offset, so we got to go fix that. So let's come to WCS, Plane Manager, Operation Side. Well, let's see, it does have a unique offset. Okay, let's try that post again. We may need to do a force tool change. Home, let's find G56. It is right there, but it's after a flip part. It's in the wrong spot. So what I'm going to do is we're going to pull up this operation, the first operation. We're going to do a force tool change, and let's do the last operation. Let's do just the first operation after flipping part. Let's make sure we also have it in the right spot. So operation side. There's operation bottom. Okay, that's what it is. This is out of order. So I need the manual entry below the facing. Now it should look better. G55, right there after flip part, and then we flip part again, now G56, and it runs off just fine, just beautiful. Okay, that is it for this lesson. If you have any questions, don't hesitate to ask, and we'll see you next time.